everyone, let's start with the next lecture. Concept of inductor and capacitor. सबसे पहले देखते हैं हम inductor. So inductor is the constant for if you give the current, then flux is produced, and the constant is called as the inductance. Psi is equal to Li. So this is the inductor. This is plus minus VL of t. This will be IL of t. Okay. What is the Ohm's law? Ohm's law is the relationship between the voltage and current. VL of t is equal to L dIL of t by dt. This is the Ohm's law. What about the current? 1 by L minus infinity to t VL of t dt. So if we divide the integration to 0 plus, this is called as the past or initial value. Initial value. So IL of t is equal to IL of 0 minus plus 1 by L 0 to t VL of t dt. और इसे ही कहेंगे हम initial current. If initial current is 0, then IL of t is equal to 1 by L 0 to t VL of t dt. Means inductor can have the previous value. So it is called as the memory element. And what is the property? IL of 0 minus is equal to IL of 0 plus. Means inductor does not allow sudden change in current. For example, this is your axis. So this is t is equal to 0 point. This will be t is equal to 0 plus just after 0 plus point, and t is equal to 0 minus past point or just before the 0. Okay, this is called as the past. This is present. Again, there is a t is equal to infinite. This is called as the steady state. So this terminology you should know. Second, we will go for the fluxing of inductor. Suppose we are assuming that inductor is getting linearly fluxed. For linear fluxing, current should be linear. So first, IL of t is linearly increasing. So what about IL of infinite? अगर increasing हो जाए तो at certain duration core will get saturated. So we will get some constant value which will be the peak value. And what about VL of t is equal to d by dt of IL of t or d by dt of increasing ramp. और increasing ramp का हमने derivative देखा था क्या है? Positive step. Positive step. So VL of t will be equal to the positive signal. Voltage will be positive signal. And what about VL of infinite at steady state? It will be d by dt of peak value or constant value, or derivative of constant value is always 0. So this is the 4 terms you should know, that current is linearly increasing, then it will attain some peak value at core saturation, then voltage is the positive value, and voltage infinite is 0. This is the about the fluxing of the inductor. Then we move toward the defluxing of the inductor. Defluxing or energy releasing of the inductor. Suppose it is defluxing linearly, then IL of t कैसे होगा? Current is linearly decreasing. IL of infinite डिक्रीज हो के मिनिमम वैल्यू कितना जाएगा? 0. What about VL of t? d by dt of IL of t or d by dt of decreasing ramp, which will give you the negative step signal. So ultimately VL of t will be equal to the negative signal. If current is decreasing, then voltage is negative, and VL of infinite or d by dt of 0 will be equal to 0. Okay, so assumption is that current is linearly increasing and decreasing, but inductor current can increase or decrease linearly or exponentially. Means current इस तरह से हो सकता है, increasing current, decreasing current, increasing current, decreasing current, increasing current, decreasing current, or increasing exponentially, decreasing exponentially. Please note that current is not negative. It is increasing and decreasing, not negative. But voltage can be negative. VL of t is negative during decreasing. Okay, but current is increasing and decreasing. It is always positive, increasing, positive, decreasing from 1 to 2 to 3 to 4, and decreasing means 4, 3, 2, 1. But it is not negative. Okay, this is the concept. Then polarity of voltage. So inductor, if energy is getting stored in the inductor, VL of t. Okay, this is inductor IL of t. So IL of t is a increasing function. Then VL of t is positive. Power is getting absorbed. Okay, and during defluxing, what is happening? This is fluxing concept. And during defluxing, what is happening? Inductor current direction will remain the same. Okay, and if we not change the polarity of the voltage, so VL of t will be equal to negative. We are writing, ये हम लिख रहे हैं negative with respect to the original polarity. Okay, अगर हमने यहाँ voltage negative लिख दिया और यहाँ हमने plus कर दिया, फिर sign कर दिया, then already polarity we are reversing. So this voltage will be positive. Do not change the polarity and keep the polarity same. Then IL of t is a decreasing function. VL of t will give the negative. Power will getting delivered because V into I will be negative. Okay, and negative power means power is getting delivered. And if we change the polarity, then what will happen? Current is living through the positive polarity, means power is getting delivered. But here we cannot say that VL of t is negative. Here it is positive. Okay. So confusion दूर करने के लिए क्या करेंगे हम? We will use one thumb rule. If inductor is given, do not change any polarities. Okay. And during fluxing, we will say IL of t is an increasing function linearly exponentially, and VL of t is positive as it is. And during defluxing, we will say IL of t is a decreasing function and VL of t is नेगेटिव. अगर ये आप फॉर्मूला यूज कर लोगे तो आपका कोई भी केवीएल कभी रॉन्ग नहीं होगा इन द सर्किट. ओके. सो लेट्स मूव टू द कैपेसिटर कैसे बनेगा? हम इफ वी गिव द वोल्टेज देन चार्ज आर गेटिंग प्रोड्यूस एंड द कांस्टेंट इज कॉल्ड एज द कैपेसिटेंस. So Q is equal to CV. And what is the Ohm's law? IC of T is equal to C dVc by dt. Okay. Then what about VC of T? 1 by C minus infinity to T IC of T dt. 1 by C minus infinity to 0 IC of T dt plus 1 by C 0 to T IC of T dt. This is called as the past or initial value. Then VC of T will become VC of 0 minus plus 1 by C 0 to T IC of T dt. This is called as the initial voltage. And what is the property? Initial VC of 0 minus is equal to VC of 0 plus, or Q of 0 minus is equal to Q of 0 plus. ये दोनों एक ही बात है. This is the property of the capacitor. Now let's move toward the charging of the capacitor. Charging of capacitor. So we assume that capacitor voltage is getting charged linearly. VC of T is linearly increasing. And what about the maximum value of VC of infinite will be peak value. Okay. What about IC of T? D by dt of VC of T. D by dt of increasing ramp, which will give you the positive step signal. So IC of T will be give the positive signal. Okay. And what about IC of infinite? D by dt of constant, which is equal to 0. So ये चार पैरामीटर हमें इंपॉर्टेंट है. वोल्टेज इंक्रीजिंग, देन करंट इज पॉजिटिव. Then discharging of capacitor. So VC of T is linearly decreasing. So VC of infinite decreasing हो के मिनिमम वैल्यू कितना हो जाएगा इसका? 0. IC of T is equal to D by dt of VC of T, or D by dt of decreasing ramp, which will give you the negative step signal. So IC of T will be equal to negative signal, and IC of infinite d by dt of 0 is 0. So this is the 4 parameter you should remember. If voltage is linearly decreasing, then current is a negative signal. So voltage across inductor can increase or decrease linearly or exponentially. Decrease का मतलब negative नहीं. If voltage is increasing and decreasing, linearly, voltage is increasing exponentially, decreasing exponentially, decreasing exponentially. Negative nahi. Okay. Voltage cannot be negative, but inductor current can be negative. Okay. Let us see direction of current, capacitor current. So one thumb rule we have seen that do not change the direction of the current and voltage. इसमें क्या आएगा? अगर कैपेसिटर चार्ज कर रहा है तो VC of T will be increasing function and IC of T will be positive signal. Okay. If capacitor discharge कर रहा है, then VC of T will be decreasing signal and IC of T will be negative. Here power is getting delivered, here power is getting absorbed. This is the concept. अगर आपने ये कैपेसिटर लिया, property of capacitor is capacitor will not allow the change in voltage polarity. ठीक है. During charging capacitor current तो ये IC of T is okay, but during discharging, if we take IC of T is like this, or current is leaving from the positive polarity, already power is getting delivered. Here यहाँ पे हमारा current क्या रहेगा? IC of T positive. But if you not change the polarity, and to avoid any confusion, do not change any current or voltage polarity and solve the KVL as it is. Okay. If you find in calculation that if current is positive, then capacitor is storing the energy, और current अगर reverse हो गया then negative, then capacitor is discharging. Okay. Simple concept. Then I will conclude that during fluxing, IL of T is increasing function, VL of T is positive, power is getting absorbed. Do not change the polarity. During defluxing, IL of T is getting decreasing, VL of T is negative because polarity has been reversed and power is getting delivered. Then for capacitor, if capacitor is charging, then voltage is linearly increasing and current is positive, then power is getting absorbed. And when capacitor discharging, VC of T is decreasing function. IC of t will give you the negative value because we have not changed the polarity. Current will flow in opposite direction with reference to the original current. So it is become negative and power is will getting delivered. So do not change any polarity for solving the KVL and KCL in the inductor and capacitor circuits. Thank you.